Hello, welcome to this lecture on modeling, analysis and estimation of three-phase unbalanced power network. In the last lecture, we have started talking about the calculation of capacitance of a transmission line. So, we have just started to review the basics. Let us again, for the sake of recollection, let us again try to review it. So, what we did that we said that if I have got a charge qx, I mean basically this qx is nothing but the linear charge density, and if I have got 2 points, any 2 points, point 1 and point 2, and if the distance of point 1 from the charge qx is given by dx1, and if the distance of point 2 from the charge qx is given by dx2, then the potential between these 2 points V12 is actually given by qx by 2 pi epsilon into log dx2 by dx1, where this epsilon is nothing but the permittivity of the medium. Now here we have to note that in this expression, first actually in the numerator, essentially the distance from point 2 to the charge qx is there, and again in the denominator essentially the distance of the charge qx from point 1 is given. So now with this expression, now suppose I do have got n number of conductors, so a, b, c, n, and all these n number of conductors has actually got the charges qa, qb, qc, qn, and because they are conductors, so then therefore we say that these conductors have got a linear charge density qa, qb, qc, qn. And then of course there is the presence of ground, and we know from the very basic electromagnetic field theory that the presence of this ground can be taken care of by assuming an image charge, and essentially these image charges have got a charge which is equal and opposite to the original conductor charge, and their distance is same from the ground. Please note that these image charges, they do not exist in reality. These image charges are nothing but the virtual charges which are considered for the calculation. So then therefore the distance from point A to the ground would be equal to the distance from point A dash to the ground. Similarly, the distance from point B to ground would be equal to the distance from point B dash to ground. Essentially, these distances are obtained by reflecting all these charges with respect to the ground. So then with these expressions, now as this quantity V12 is essentially can be expressed by the superposition of the voltages contributed by each and individual charges. So then therefore the potential between point 1 and 2 would be given by the potential due to charge qa plus the potential due to charge qb plus the potential due to charge qc dot 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 plus the potential due to charge qn, and then plus the potential due to charge minus qa, due to charge minus qb, due to charge minus qc, and then dot 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 due to charge minus qn. So basically that's what we have actually here written, that V12 would be 1 by 2 pi e we have taken common, and then due to charge qa would be qa into log dA2 by dA1, where actually dA2 is nothing but, so I would say that for example here I can write down in this expression that dx2 is nothing but distance of charge x to point 2 and similarly dx1 is the distance of charge x to point 1, and of course x would be taking the values a, b, c dot 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 n. So then therefore the values of x would be a, b, c, n. So a, b, c, n, and then this charges would be equal to. So then with this notation, so then therefore V12 would be 1 by 2 pi epsilon qa into log dA2 by dA1 plus qb into log dB2 by dB1 plus dot 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 qn log dn2 by dn1. So these are the expressions of the voltages due to these charges A, B, C, N, and then here we are going to take into account the effect due to these charges. So this is minus qa into log dA dash 2 divided by divided by dA dash 1 minus qb log dB dash 2 by dB dash 1 and so on and so forth minus qn log dn dash 2 by dn dash 1. So with this notation now we are going to consider that what happens to the potential between point A and A dash. What happens to the potential between point A and A dash. So for that we are going to denote some notation. So we would say that this distance, that is from A to A dash, that is from this charge to the to its counterpart image charge, is given by say HA. Similarly, this distance is given by HB. Similarly, this distance is given by HC. Similarly, this distance is given by HN. And we also say that this distance from point A to point B, from point A to point B, so this distance is DAB. From point A to point C is DAC. Similarly, from point A to point N would be DAN. Similarly, from point B to point C would be DBC, and so on and so forth. Alright. So then therefore, I can write down, and then we also say that the distance from point A to point B dash is given by say HAB. So it is basically the distance between point A and the image charge of B dash. Similarly, the distance between point A and point C dash would be given by HAC. So for example, it would be HAC. So this is HAB. So I would say that this is HAC. HAC. So this is HAC. Then similarly it would be HAD, then HAN. Now obviously if this is HAB, so then obviously from B to A dash also would be, from the very simple geometry, from B to A dash would also be equal to HAB. For example, so if I say that from B to A dash, also from the very simple geometry, also it will also be HAB, right, because these 2 points are nothing but the exact reflection of the original charges A and B. So then therefore, so with these notations, let us write down this notation. So I denote that dxy is the distance between original charge x and y, right? Original charge x and y, where x and y all are varying from a, b, c to n, with the condition x is not equal to y. Now here we know, if this distance between point A and point B is DAB, and because A dash and B dash are nothing but the reflections of point A and B with respect to the ground, so then therefore the distance between point A dash and B dash, this distance also would be DAB, correct? So then therefore this also can be written as that these basically the same distance or be also equal to the distance DAB. So then therefore I can write down that this is also, so I would say that this is also, so let's write, so this is also distance between the image charges x dash and y dash, x dash and y dash, where x dash y dash is equal to a dash, b dash, c dash dot n dash, and with the condition that x dash is not equal to y dash. Right? And we also denote that hx. Hx is we denote as distance between charge x, between original charge x, and its image charge x dash, right, where x is a, b, c, n. So again, just for recollection, HA is nothing but the distance between A and A dash, HB is nothing but the distance between B and B dash, HC is nothing but the distance between C and C dash, HN is nothing but the distance between N and N dash. And we also denote HXY. HXY, it is distance between charge, original charge x, and image charge y. Image charge y, where x varies from a, b, c, n, y varies from a dash, b dash, c dash, n dash, and with the condition that y is not equal to x dash. right? So for example, if x is a, so then therefore y cannot be a dash, y would be b dash, c dash, n dash. If let us say x is c, y cannot be c dash, right? Because the distance between c and c dash is being defined by hx, right? So then therefore this notation is for only this condition. And this is also equal to, I can say that this is h y x, right. So this is also the charge dy x, or rather this is also equal to the distance dy x. And then we also denote something called rx. Rx we denote as radius of conductor x, where x is equal to a, b, c, n. So this is the radius. So now with this, so what would be v a dash? So with this, what would be v a dash? Now if I you now basically to compute this, if I try to use this expression of let us say V12, so I can simply say that here in this case a is equal to 1 and a dash is equal to 2. And so then, and we said, so then therefore the common would be 1 by 2 pi, and then first term would be qa log, and then what is the case? Case is that the distance of qa to point 2 divided by distance of point A to point 1. Now here the distance of charge A to point 2 means point A dash is given by HA, and then distance of charge A to itself, and here we assume, or rather here we know that all the charge is always basically residing on the surface. So then therefore this particular self distance would be equal to its own radius. So then therefore it would be log HA by RA, right. So it would be log HA by RA. For QB, log, so it is from charge B to the charge A dash, I mean basically that would be the distance, and of course that would be HAB, we have already said HAB divided by point B to point A, that is given by DAB, correct, plus QC, it would be log, it would be HAC divided by DAC plus dot 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 plus Qn log HAN divided by DAN. Please note HAC is nothing but the distance of charge C to point A dash, right, and DAC is nothing but distance of charge C to point A, because we are trying to calculate between point A and A dash. Similarly, QN is HAN is distance of charge N to point A dash, and this is the distance of charge N to point A. So these are the contribution of the voltage due to the original charges. Now we have to look into the contribution of the voltages due to the image charges, so QA. So here log, now when QA, so that means we are now considering this charge. Now when we are considering this charge, still this is 0.2, so then therefore in the numerator it would be essentially the distance of this charge to itself, and again by following the simple rules of electromagnetic field theory, we know that these image charges will also reside on the surface. So, then therefore, this self distance would be equal to R A and then divided by the distance of this charge to point 1. So, that is H A, right. So, this is due to minus q, then minus q b, it would be log due to log divided by, so now we are considering this charge. So, then therefore, in the numerator would be the distance from this charge to point 2, that is a dash, and we have already said that if this distance is dab, so then therefore this distance would also be dab. So, then therefore, it would be dab divided by distance from this point to point A, right. So, that is nothing but HAB. So, it is just the reciprocal. Similarly, so we can now proceed similarly same fashion, log DAC by HAC minus dot 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 minus QN log DAN by HAN. So, this is the expression. Now, let us look at these expressions. So, here from in this expression, so in this and this I can take common QA. Now, if I now here if I now just look at this, so what I get, if I now just look at this, now let us write now QA log HA by RA minus QA log RA by HA. If I take QA common, it would be log HA by RA minus log RA by HA, right. And we know that log A by B is equal to log A minus log B, that we already know. So, if I apply this, so that would be is equal to QA log HA by RA into HA by RA. So, it would be HA by RA whole square. So, that would be 2 QA log HA by RA, right. So, then therefore, if I do combine these two, so these two combination would turn out to be 2 QA log HA by RA, and these two would be cancelling out. So, it would be 1 by pi e into QL. And again, if I do now combine this and this, so again I can very simply see that it would be also equal to plus 2 QB log HAB by DAB. If I combine these two together, QC and minus QC, it will turn out to be by the same process. It would be plus 2 QC log HAC by DAC and then dot dot dot. Lastly, if I do combine the expressions due to Qn and minus Qn, these two will come out to be plus 2 Qn HAN by DAN. So, then therefore, I can write down that VAA dash, and because 2 would be common everywhere. So, then therefore, these 2 would cancel out with this 2. So, then therefore, it would be basically 1 by pi epsilon log QA log HA by RA plus QB log it would be HAB by DAB plus QC log HAC by DAC plus dot 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 QN log HAN by DAN. So, sorry, this would be VAA dash. So, that would be VAA dash. Correct? Because you see, because everywhere 2 will come out and that 2 will cancel each other. So, that would be the case. Now, in this diagram, if I wish to find out VA, so that is the potential of point A due from the ground, and so then it will be nothing but half of VAA dash, because these two are at the same distance. So, then therefore, I can write down, so therefore, I can write down VA is equal to 1 by 2. I should write it down. I should write it down. Half VAA dash. So that would be equal to 1 by 2 by A QA log. So this is the expression of VA, right? Similarly, if I write down, so now you see, similarly, if I now write down the expression of VB B dash, so what I will write? So VB B dash would be, so VB B dash, so first would be due to point A, right? So I am trying to just, so then therefore now let us write down that what is the, again, what would be VB B dash. So I can write down from here 1 by 2 pi E first we take the charge QA. So again, when it is BB dash, so my B is 1 and B dash 2. So first distance would be from QA to B dash, right? So from QA to B dash and then QA to B. So QA to B dash is HAB divided by DAB. So it would be QA log HAB by DAB plus QB log, it would be HB by RB plus QC log, it would be from charge C to B dash. So this distance would be from charge C to B dash. So here it is nothing but, now this distance from charge C to B dash is essentially nothing but HCB, right? So it is HCB. So it is HCB divided by charge C to charge B. So it is DCB, DCB, or rather I can write it down as DB's HBC, HBC, I can write it down as BC. HBC DBC dot 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 QN log HBN and DBN. Right. So these are nothing but the potential contribution due to original charges, and then minus QA log just reverse DAB by HAB, because from this charge QA to B dash, so then this distance is DAB, and then minus QA to B, that is HAB, right. Then minus QB log RB by HB minus QC log DBC by HBC minus dot 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 minus QN log DBN by HBN. Same process. So it would be nothing but 1 by pi e, then QA log HAB by DAB plus QB log HB by RB plus QC log HBC by DBC, and then dot 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 QN log HBN by DBN. So then therefore VB is nothing but half of this so QA log HAB by DAB plus QB log HB by RB BC by DBC, and then so this is the expression of VB. In the same manner, we can write down the expression of VC, VD, VE up to Vn, and then we can simply take these equations together and then see what happens. So we will continue with those. We will actually continue with this derivation in the next lecture also. Thank you.